All right, so this lesson is starting chapter 6. Chapter 6 is all about exponential and logarithmic functions. So we're going to start out by talking about exponential functions. So this is chapter 6.1, part A, and we're going to talk about these exponential functions today. So the first thing you need to know is that the exponential parent function looks like this equation. F of x equals b to the x. So your x is your exponent here. So a constant raised to an exponent. This b term right here is going to determine whether this exponential function is going to show growth or decay, whether it's going to increase or decrease. So if this number b here is greater than 1, so any value greater than 1, then the function is an exponential growth. Exponential growth. And that graph will be increasing. Now, if b is less than 1, then the function is an exponential decay. Exponential decay. And it will be decreasing. Another key term you need to know is asymptote, and we've talked about asymptotes before. An asymptote is a line or an imaginary line. You don't actually draw this line. Sometimes you draw it as a dotted line or a dashed line, but it's a line that the graph gets close to but never touches. A line that the graph gets close to, but never touches. Alrighty. So let's look at graphing these and then finding the key features. So I don't know if I mentioned this, but that is your learning target. I can graph and identify key features of exponential functions. So we're going to graph them and then describe the key features. So the first thing you want to do is make a table of values. So I'm given this equation here, x, or 2 to the x, and then I'm going to make my table of values. So for your x values, you're picking these yourself. But I want to stay small. I want to stay around the origin here so my numbers don't get out of control. So the numbers I'm going to pick for x are -2, -1, 0, 1, and 2. Again, these are just numbers you're picking. Now once you have those x values, you're going to take this x value and plug it into the x in your equation. So to find y, I'll take my x here, -2, plug it in, so I have 2 to the -2. And you can figure that out yourself, or you can just throw it in your calculator. 2 to the -2 is 0.25. Then plug in -1. 2 to the -1 is 0.5. Plug in 0. 2 to the 0 power is 1. 2 to the first power is 2, and 2 squared is 4. So now I have my ordered pairs here, and I'm going to graph them. So that's step 2, plot your points. So -2, and then the y value 0.25. -2, 0.25. Now -1.5, 0, 1, 1, 2, 2, 4. 1, 2. 1, 2, yep, there we go. Okay, just double checking. And then just connect your dots there, and you see your graph. So there's a couple things I want to point out here. So we read our graphs from left to right, and from left to right it's going up. So this is increasing, which is an exponential growth, which makes sense because our b value 2 is greater than 1. So this is showing growth. All right, so I have my graph. Now I'm going to find my key features. Here are the key features over here. We need to find domain, range, end behavior, y-intercept, and asymptote. So I'm going to use my graph to do this. Domain, remember domain is the x values. So x values left to right. So what are these x values doing? Well, x is going further and further this way. So from negative infinity, then further and further this way to positive infinity. So negative infinity to positive infinity, or you can just simply say all the reals, all real numbers. So that fancy R is a symbol for all real numbers, okay, which is the same thing as negative infinity to infinity. All right, range is your y values, lowest to highest or bottom to top. Now, it's important to know the asymptote here. So if you look at this graph is getting closer and closer to the x-axis, but it's never going to cross it. So this x-axis is called y equals 0. So this value right here, the y value is 0. So our asymptote is y equals 0. And that helps me determine my range. So I know that the y values are going to be greater than my asymptote because it's above the asymptote. So the range is all the y values greater than 0. Now I need to find my end behavior. So what are x and y doing at the ends of the graph? So I'm looking at the ends, and I want to know what is x doing and what is y doing. So as x approaches infinity, which would be over here on the right side, what is y doing? So what is y doing on the right side? Well, it's going up. So f of x, or y, is also approaching infinity. All right, well, what happens on the left side here? As x approaches negative infinity, what is y doing? Well, y is getting closer and closer to our asymptote, which is 0. So y is approaching 0. And then finally, your y-intercept, that's just where the graph crosses the y-axis. So this point right here, and that's the point 0, 1. Okay, let's try another one. So let's look at number 2 here. F of x equals 3 to the x there. So I'm going to make my table. Step 1 in our success criteria is to make a table, and remember you're just picking any x values. I'm just going to keep them small around the origin, so that's why I picked those. Now take those x values and plug them into your equation to find y. So plug in -2 in for x. So 3 to the -2. Throw that in your calculator. That's 0.1 repeating. -1. So 3 to the -1 is 0.3 repeating. 3 to the 0 power is 1. 3 to the first power is 3. And then 3 to the second power, 3 squared, is 9. So I have my table. Now I'm ready to plot my points. So -2, positive 0.1, -1, positive 0.3, 0, 1, 1, 3, 2, and 9. And then, whoops. Make my curve here. So we've got another growth, exponential growth, because it's increasing there, and our b value is greater than 1. Okay, now I'm ready to give my key features. So domain goes negative infinity to positive infinity, so all the reals. Range, remember we're looking at our y values, so here's my asymptote at y equals 0. So that means my y values have to be greater than 0 because the graph is above 0, but it's never going to touch 0. And behavior, so what is the graph doing on each end? So as x approaches positive infinity, that would be the right side. What is y doing on the right side? Y is going up to infinity. All right, now what is y doing on the left side? That's where x is getting closer to negative infinity. So what is y doing? It's getting closer to 0. It's approaching 0. And then where does the graph cross the y-axis? Right here at the point 0, 1. All right, so now let's turn our note paper over. Pause the video. You have number 3, 4, and 5 to do. So go ahead and pause the video and try those. All right, let's check your work here. So here's number 3. You can pause it as you need. Here is number 4. Pause as you need. And number 5. All right, so that's our first learning target, graphing these exponential functions and giving all the key features. So now we're going to move on to our second learning target. So this is I can describe and graph transformations of exponential functions. And we're familiar with this. We've done a lot of these transformations. We've done transformations with quadratics and with reciprocal functions, and then we've even explored some other functions as well in the past. So we're going to apply those same concepts that we know to these exponential functions. So let's start out by just giving the basics. So here is your basic graph. So we've already talked about the parent function. The parent function is f of x equals b to the x. So I'm going to put pf for parent function. And then we can add all these other components to it to make the graph become a transformation. So you can multiply by a value in front, and we'll call that a. So if a is greater than 1, that's a stretch, vertical stretch, and then less than 1, so a fraction less than 1 would be a compression. All right, if that a is negative, so you have a negative in front here, that is a reflection across the x-axis. And we've seen these before, these reflections. Now here's something new, and it's not on your sheet, but what if this exponent is negative? If that happens, then it's a reflection over the y-axis. So keep that in mind. You might see that. All right, so what about this h? So h is going to be your horizontal shift. And if it's plus h, if you're adding h, it's going to shift to the left, and a minus h will shift it to the right. Again, We already know all these rules. This is just kind of a refresher. And then this plus k, that's going to be your vertical shift. If you're adding k, that's going to move it up. Subtracting will move it down. Okay, so let's put this into practice. So this is all your success criteria for describing transformations. So ignore this for a minute right here, this success criteria. We're going to use this below. So right now we're just going to describe. So the first thing you want to do is identify the parent function. What is this function in its simplest form? So for number 1, your parent function would be f of x equals 3, so the b is 3 to the x. So that would be your parent function. Now what does this plus 5 do? So the plus 5 is that plus k, and if you're adding, you're going to go up. So this is going to be moving the graph up 5. And that's it. All right, let's do one more together, and then I'll let you do the next 2 on your own. So number 2, you want to take it down to just the basic parent function. So that's that form, f of x equals b to the x. So f of x equals, our b would be 1/4 here, and then to the x. So there's your parent function. Now, what does this 2 in front do? This is your a term, and it's greater than 1, so this is going to be a stretch. So I'm going to say this is a stretch by 2. And then this -1 here is going to move it to the right. So it's going to go right 1. All right, you try 3 and 4. Let's see how you did for 3 and 4. So we have a parent function here. F of x equals 4/3 to the x. This is going to be a reflection over the x-axis, and then it's going to go left 2 and up 7. Parent function for number 4, f of x equals 5 to the x. And then we're going to have a compression of 1/2. It's going to go right 4 and down 2. All right, now let's get into graphing these. So here's, go back up here. Here's your success criteria here. I just put it up there because I had a little space. So just like what we did before, you want to identify the parent function and describe all the transformations happening to this parent function. So we're going to start out by doing that. So for number 5, your parent function is f of x equals 2 to the x. And then this plus 5 is going to move it left 5. So you should see this graph shifting to the left. Okay, so now we're ready to graph it. Now you could make a table of values like what we did for the more simpler ones for our last learning target. But these can get kind of complicated. So what I'm going to have you do is I'm going to have you use Desmos. So I'm going to have you plug in the given function here. So you're going to type in 2 to the x plus 5, 2 to the x plus 5 into Desmos, and then use your computer to find these things. So I'm going to plug that in, 2 to the x plus 5. Pause the video, go ahead and get to Desmos and do that. So you should see some things. You should be able to see the graph now. I'm going to give like a rough sketch here of what that looks like. So it looks something like this. You should see something like this on your computer screen there. So to use this, I'll see the domain. Domain is all the real values, or negative infinity to positive infinity, all the reals. And then my asymptote, this is getting closer and closer to the y equals 0, which tells me that my range has to be all the y values above that, because the graph lies above that, so y greater than 0. Then I can fill in my end behavior. As x approaches infinity, positive infinity is over on the right side, y is going up to infinity. And over on the left side, as x approaches negative infinity, y is getting closer and closer to that asymptote of 0. And then the y-intercept, you're going to have to click on your graph and kind of follow it up until you see where it crosses this y-axis. So kind of drag your mouse until you see that point, and you would be at 0, 32. Okay, let's do one more together, and then I'll let you do the last 3 on your own for practice. All right, number 6. So start with the parent function. F of x equals 1/3 to the x power, and then this is going to go down 2. And notice this is a b value less than 1, so this should be a decay. So it should go this way. It should decrease. So go ahead and put this in Desmos, and then you would graph it. Looks something like this, just to save time. So the domain is all the reals. Range, so you're finding your asymptote is right here at y equals -2, which means y has to be greater than -2. On the right side here, y is approaching -2, and on the left side, y is approaching positive infinity. And then your y-intercept is the point 0, -1. All right, pause the video, try 7 through 9. Here's 7, 8, and 9. Okay, you're ready to do your practice homework, your OTI.